Okay, so this is day 2 of transformation. So today we're going to focus more on if we have the actual graph, figuring out what the transformations were, which ultimately means finding what the equation of that parabola is. So that's what we're working on today. So it's kind of like the reverse of what we did yesterday. So first off, let's talk about the order of the transformation. Do they matter? The answer to that is yes. So think of transformations like bed mass. So yes, they most definitely matter. This is a big yes. Reflections and stretches / compressions happen first. And then we'll do the horizontal and vertical shifts. Okay, now something else that, this is just an aside, it's a pattern that you'll notice that will happen that can help us figure some stuff out. It's not always useful, but you're better having more knowledge than less. So if x is equal to 0, y is 0. X is 1, y is 1. I'm using y equals x squared here. So then we have 4, 9, 16, 25. So I'm going to look at my first differences. I have 1, 3, 5, 7, 9. So this can help us with our graph because as we're going from 0 to 1, we're going over 1 and up 1. We're going over 1 and up 2 to get to 3. So this is kind of helping us follow our pattern here. And then also 3 subtract 1 is 2, 2, 2, and 2. The a value is always going to be the second difference divided by 2. So in this case, 2 divided by 2 is equal to 1. That is definitely the a value that we have here. All right, so then let's actually look at an example. Okay, so given the following graph, determine which transformations have been applied. There are a few different ways of doing this, but in my opinion, the easiest way of doing it is determining what the equation is. So I am going to start by writing my equation as y equals a times x minus h all squared plus k. So then the next thing I'm going to do, so that's my first step, is write the equation. Second step, I'm going to sub in the vertex. So for this one here, we're going to have y equals a. The vertex is 0. So I have x minus 0 squared plus 0. So this gives me y equals a x squared. So the problem is I don't know what a is. So a tells me if it's been stretched or compressed. So I need to figure that out. So for step 3, I'm going to identify a nice point or exact point. So when I look at this graph, I see that right here at 1, -3, it's an exact point. So I've got that point. So I have negative, sorry, not negative. So I have 1, -3. Oh my goodness. 1, -3. So as you probably guessed, that gives me a value for x and it gives me a value for y. So I'm going to sub in the point. So y is -3. I don't know what a is, and x is 1. So in this example, -3 is equal to a. So that means my equation is y equals -3 x squared. If I give you that equation, you should now know that we have a reflection of the x-axis, and we have a vertical stretch of 3. Okay, so that's how we can figure out without error what transformations have happened. So it should make sense that you ended up with a negative a value because you know that the graph is opening downwards, so therefore you have a reflection occurring. All right, so let's do another example. Right, so this one right here. So I'm not going to write out all the steps quite like I did before. I'm just going to go ahead and do it. So I'm identifying my vertex, which is at 3 and 2. So I'm going to have y equals a x minus 3 squared plus 2. So that's my first step. Next, I'm going to identify a perfect point. So I'm choosing to identify this one because it's exactly at 5 and 6. So now I'm going to sub that in. So I have 6 equals a 5 minus 3 squared plus 2. My ultimate goal is going to be to get that a by itself. So I'm going to subtract 2 from both sides. So I get 4 equals a times 2 squared. 4 equals a multiplied by 4. I want to get a by itself, so I'm going to divide. So 1 is equal to a. So that means my equation is y equals x minus 3 squared plus 2. So there's been no stretches or compressions or reflections. So then when I state my transformations, I'm going to say that we have a shift 3 units right and a shift 2 units up. All right, so the fact that A isn't negative makes sense because it hasn't been reflected and that graph hasn't been transformed. Okay, so let's move on to our last example that we're going to look at like this. So now we have this graph. So looking at that graph right now, it's on the same grid as the other ones. It definitely looks like there's been a compression happening. So I'm expecting my A to be a value between 0 and 1. I'm not expecting a negative because it's not reflected. So same idea, I'm going to identify my vertex. So this vertex is at -2, -3. So I'm going to start y equals a x plus 2 squared minus 3. So remember inside, actually, you know what? I'm going to show this one slightly different just to emphasize something. So I have y equals a x minus -2 all squared minus 3. So I just really want to emphasize that when things are moving to the left, this is what's happening mathematically. Okay, so I got that part. Now I'm going to pick a point on the graph. So when I'm looking at it, this point right here at 2 and 5 looks pretty exact. So then I'm going to sub that in. So I'm going to have 5 equals a 2 plus 2 all squared minus 3. So I'm going to add 3 to both sides. So we get 8 is equal to a multiplied by 4 all squared. So 8 is equal to 16a, because that's what 4 squared is. I divide both sides by 16 to isolate. So I get 1 over 2 equals a. So then I'm doing my happy dance because I expected there to be a compression. So that meant the value of a had to be between 0 and 1, and it is between 0 and 1. So that means the equation is y equals 1/2 x plus 2 all squared minus 3. So I have to list 3 transformations. So there's a vertical compression of 1/2. There's a shift left 2 units. And there's been a shift up 2 units. All right, so that describes the transformation with very exact values in terms of the parabola that's on the graph. So hopefully that makes sense. So the key is identifying the vertex and substituting a point into the equation and isolating for A. Again, if you have any questions, don't hesitate to come see me.